Okay, there's two problems in this one, okay? The first problem states that how many liters of C2H6 at STP are required to produce 22 grams of CO2, okay? First of all, I have C2H6 plus O2. What type of reaction? Combustion, okay? So what are my two products?
CO2, H2O.
Yep, CO2 and H2O. Okay, before you do any stoichiometry, what do you guys have to have? Balanced chemical equation. So we need to balance that. It has a hydrocarbon in it, so what should you do first? Balance two first. Carbon, then hydrogen, okay? So if I put a 2 here, right, what would I have to put over here? A 3, but that gives me an uneven number of oxygen on the right side. So what should I do if it doesn't work the first time? Yeah, so we need to put a 2 here. Now balance. How many carbons? How many? 4, okay. How many hydrogens? Put a 6 there, and then now how many oxygens? 7. Because that gives me 8 plus 6 is 14, so 7. Okay? So now I have a balanced chemical equation. Okay? So the first part is at STP. Okay? So what do I want to start out with? If it's at STP and what's the only number you see? All right, 22 grams of CO2. So I start out with 22 grams of CO2. What's my first step? Okay, divide by the molar mass and convert to moles, correct? Oops. So 1 mole of CO2 is 3244.01. So my grams cross out. What would be my second step? Mole to mole ratio. What is the mole to mole ratio between who? Yeah, between CO2 and C2H6, which is what? 1 to 2, and so how do I put that in order for it to cross out? Okay, so for every 1 mole of C2H6, I have 2 moles of CO2. Okay? Now, before we go any further, any questions? Everybody's good. Okay, now, there's 2 ways we can do this. The easy way is because it's at STP, what would be my next step? Yeah, the 22.4 moles. 20 liters equals 1 mole. So for every 1 mole of C2H6, I have 22.4 liters. So my moles cross out. Okay? So now I do my math, in which I take 22 times 22.4 and divide that by 44.01, and then I divide that by 2. And how many sig figs do I need?
2.
2, so what's my answer? Yes, 5.6 liters of C2H6. Okay. Now we were able to do that because it was at STP. Okay. The second question now, it says how many liters of C2H6 at 25 degrees Celsius and 3.2 atmospheres? Can we do it this way? No, we have to do a certain part of that, but then what law do we have to use? We have to go to the ideal gas law, okay? So I'm going to erase this last half. Okay, so I'm going to do the same thing. I'm going to take the 22 grams and change it to moles, and then what's my next step? Yeah, I need to find out the moles of C2H6. So I use the mole-to-mole ratio again of 1 mole of C2H6 for every 2 moles of CO2. Okay? Now, do I continue or do I solve? I need to solve. I need the moles of C2H6 because I am not at STP. And I have to use ideal gas law, so I need to know what the moles of C2H6 are. Okay? So in this case, I just take 22 divided by 44.01 divided by 2, and I need 2 sig figs, so that gives me 0.25 moles of C2H6. Okay? Now, what do I do? Okay, now I have to plug into the ideal gas law, all right? What is my pressure? What's my pressure? Okay, so my pressure is 3.2. What's my volume?
Unknown.
Unknown, so B. What's my number of moles? 0.25. What R am I going to use? I'm going to use the 0.0821 because this is in atmospheres. And then what is my temperature? 298. Okay, so now I solve for B. So I take 0.25 times 0.0821 times 298 divided by 3.2. And what do you guys get if I need 2 sig figs? 1.9. What's my unit? 0.9 meters. So guys, those are the 2 ways that you have to do your homework. If it's at STP, you can do it all in one step because of the 22.4 liters. If it's not at STP, then you need to calculate the moles of what you want, and then you have to use the ideal gas law to plug in. Okay? Any questions on that? Everybody's good? Okay. The only other thing that I need to tell you guys is we haven't really talked about it, but what is an ideal gas? Since we're using the ideal gas law, what is an ideal gas? What does it mean to be an ideal gas? Okay, we have an ideal gas versus a real gas. Anybody know the difference? Because it's the ideal gas law, so it would mean that the gas is ideal, but what does that mean?
Uncontaminated.
Guys, an ideal gas means that it's a gas that has no volume. Okay? And it also has no attraction for each other, between the particles. What is wrong with that definition? What is wrong with that definition? Why is it impossible? You cannot have matter without volume. Do you not have to have mass and volume to be matter? Okay, so ideal gases do not exist. Okay, all right, but real gases do. And real gases have volume. And real gases have attraction between the particles. What does this allow us to do? If we had an ideal gas, we wouldn't be able to do this. But because we don't have real gases, we actually have real gases, what does that allow us to do with the gas? No. Good guess though. Guys, because the real gases do have volume, okay, all right, and we can be able to measure its volume through the gas laws, all right, and because it has the attraction between the individual particles, it allows us to be able to condense a gas, and it actually allows us to solidify a gas because of the attractions to the particles. If this was the case, then we have a very difficult time trying to condense and solidify a gas, okay? So in the case that we're working with the laws, the ideal gas does not exist. We are, a real gas is what we're using that, most real gases behave like ideal gases, except that they have volume and they are their particles do attract one another, okay? All right, so that is the difference between, the two. All right, just in case you might see that little question on the text on Wednesday. All right, there's one more thing, and you guys are responsible for it. You guys need to study Graham's law. You do not know how to do the math. You just have to know what Graham's law is. Okay? All right, you do not have to do the math of Graham's law. You just have to explain what it is. Okay? All right? Any questions in regards to anything we've done? Yes?
About ideal versus real gases, why is it that we call it the ideal gas law then? I mean, what is it about?
Because the majority of real gases behave like ideal gases. But so what we want to do is we want to try to we're trying to measure a gas as an ideal gas, but we know it doesn't exist. So the ideal gas law has volume, which an ideal gas does not have volume. So it allows us to be able to determine different scenarios at different temperatures and at different pressures, what's going to happen to the volume of that real gas. If it was an ideal gas, we would not be able to calculate the volume if we change its temperature or pressure. I know it's very confusing. That's why the ideal gas doesn't exist. Okay, we would not be able to measure anything of an ideal gas because of its volume. It has no volume.
What makes an ideal gas something that we care about though?
It's in theory.
Okay.
Okay, it's in theory that based on how a real gas behaves, we should be able to calculate what would happen if we change any of the variables. Okay, and that's how we came up with the ideal gas law and the other gas laws, because most real gases behave like ideal gases.
Okay.
Okay, but it's in theory. Okay, everything's in theory.
Actually, that's great.
All right, so you guys have the rest, both of those, worksheet and lab needs to be on my desk before you leave, okay? And I will pass back your mass labs, Anna and Caitlin.